All right. Hi everyone and welcome to a nice recap video for MongoDB. We'll be deep diving into the syntax of MongoDB, understanding what is this thing called CRUD, the Mongoose library, and building an end-to-end authenticated application. If you already know MongoDB well by now, I would urge you to target the assignment yourself. But if you've been struggling with the assignment this week, then this video is for you, where we first go through MongoDB again and then target the assignment from week 4 together. Let's get right into it and let's start to understand databases with some real world examples. Let's say you're an angry person who wants to go to some court for some, legislative things. You want a divorce from your wife, haha, or you want to file an FIR, someone stole something from you. You will first probably go to your local court and submit some documents. They'll go sit in some central place. If you lose from here, or if judge one leaves from here and then another judge comes because the first judge retired, the new judge will come and then you will be dealing with them. The judge keeps changing. If you lose in the local court, you might go to high court. If you lose in high court, you might go to Supreme Court. Throughout, you will be interacting with 10 different judges, but there will be a central place where all of your data would be stored. What do I mean when I say data? Things like all the evidences you have provided against your partner, ke haan, they've been cheating on me, haha, look at these photos. Or if someone stole something from you, all the evidences, all the previous proceedings, things like these will be present in some file in some central place. This place is incredibly secure. Courts can change, judges can change. If the court burns down, it is fine. They'll just create a new one. You will go here. Courts are transient. This data is permanent. If there is a fire here, then all this data is lost, which is why this is kept really secure. This keeps on changing. What is a database in the real world? It is a place where data is stored persistently. It is similar to this file cabinet database, which needs to hold data almost forever. The browser interacts with HTTP servers, and HTTP servers are transient. These can go up and down. In fact, servers auto scale. You might hit one server first, which interacts with your main database. You might hit another server some other time. Database is the thing that's always the same. Servers go down, they are transient. Database is persistent. It will stay there forever. If you lose this, if you have a single server where your data is stored and that data center has an earthquake, has a fire, then your data is lost forever. This is true for even Facebook or Google or Instagram. If they've stored their data in a single place and that data center burns down, they lose that data forever. This is why databases are also replicated in multiple places. You won't see that here in the court example. Court mein to the file is present in a single place and the hope is nothing burns down here, even though in Bollywood movies sometimes it does. People steal data from here. But in the real world, like in applications like Instagram and Facebook, data is replicated in multiple data centers. One in India, one in US, one in France, one in Australia. That way, in the worst case, if there is some earthquake in one place, the data will be present in a different place and vice versa. So even though you might think from this diagram, there is a single server where the data is stored. No, it is usually a cluster of servers. But the thing to keep in mind is usually once you have brought them up, they always stay up forever. If let's say you have one database in India, one in the US, and your lease is ending with the data center in the US. What you do is you create a copy of it, make sure this one is up, and then move over to another data center in the US. But generally, there is always a single central place where this data is always stored, which is different from these servers, which frankly go up and down throughout the day. Express servers, HTTP servers can be incredibly transient. As long as you have enough to serve the current traffic, you can just send traffic to various servers. Database, completely persistent. Examples of the data that is stored in a database. For an application like LinkedIn, the data that is going to be stored in this place right here would be the user data, their username, profile picture, first name, last name, email, password, their posts, all the posts that they've made here, their connection relationships, which means who am I connected to, who have I sent a connection request, who has sent a connection request to me, things like these, and the message history between two people. So like what messages did Harkirat send to some other person and vice versa. These are like just a subset of things that are stored in case of a LinkedIn example. And how does the request usually go by? You hit an HTTP server and ask, bro, please give me my current feed. Tell me what all posts are present here. the Express server does some authentication checks. Basically means makes sure that you actually have access to this data that you're trying to access. Basically gets your cookie information or headers that we've talked about, JWT, decodes them, makes sure you are Harkirat, and then hits the database, gets all of your posts and returns them back to you. A good question you should have at this point is, okay, why don't we let users hit the database directly? Why do you even need this HTTP layer in the middle? Why can't the user talk directly to the the database? What extra does the HTTP server provide you exactly? And this is the answer. Databases, this one's like not a very small reason for it, but still a reason. Okay, databases were created using protocols that browsers don't understand. Browsers can talk HTTP. If you send the fetch request out, it goes to an HTTP server. It gives you back the response. The fetch request is able to understand and encapsulate data in HTTP format. That is not true for a MongoDB database or a Postgres database. Your browser can't really talk directly to a Mongo database. It doesn't understand that protocol. This is a small reason. You can somehow still make your browser talk to MongoDB. If this was really a very big product market fit, okay, browsers should talk directly to databases. People will figure this out and figure out a way for browsers to talk directly to databases. The biggest reason this does not happen is databases don't have granular access as a first class citizen. This is a convoluted statement. What do I mean when I say granular access? I mean that databases are like, whoever has my password has access to the whole database, which means all user data, all user posts, all connection information, all messages. It's a very 0-1 thing. Browsers either give you access to databases either give you access to everything or give you access to nothing. You cannot expose a database in a way the database will give you access. If you give me this password, you will have access to this user's data. If you give me this password, you will have access to this user's data. You have one password. If the user who's hitting that request has that password, they have access to the whole thing, else they don't. So if you expose this directly to the browser, if the browser can directly talk to the database, that means whoever is present here, the client, which in this case is Harkirat Singh, can ask the database for any data. This is why you need the layer in the middle. As you can see, it says does auth checks. It does authentication checks. Express server has complete access to the database. It needs to restrict access based on whoever is sending the request. If the request that is being sent by is Harkirat, he will see his own posts. The Express server will hit the database with a subset query. Okay, give me data only for Harkirat. Even though I can get data for everyone, just give me data for Harkirat because that is who is asking me this for the feed. So the biggest reason you need a server in the middle is to do authentication checks. And the other reason was, browsers can talk HTTP. Browsers can't really talk to the database directly. But there are exceptions. There are some databases like Firebase that let you get rid of HTTP servers and try their best to give you granular access. So one such database or one such technology, call it whatever, that came into the picture was Firebase, which was a company that eventually Google acquired, which literally brought a paradigm shift. We are a database and we let number one, browsers talk to us or even mobile apps talk to us. And number two, we let you fine grain access to data. You can somehow here put some rules. If the person who's asking information is Harkirat or has a certain user ID, only give them access to these resources. So it isn't necessarily true that you always need an HTTP server in the middle. There are databases that came out that get away from them. But generally the architecture followed in most places is this. You have an HTTP server, you have a database, and you have the client hitting your HTTP server. All right. Databases usually allow access to 4 primitives. So here you need to understand the thing called CRUD. Generally, any database will let you do 4 things: create data, read data, update data, delete data. That is all that a database needs to support. Given a user's request, it needs to support 4 types of requests. Either let the user create data, either let the user get some data, update data, or delete data. Few examples are when you sign up, the Express server will hit the database with a request to create data. Basically tell Harkirat with this email and this password has signed up. Read data. Whenever you hit the database, give me all the posts for myself. This would be asking the database. The Express server would ask the database, give me back all the information for Harkirat or all the posts for Harkirat. Update data. Whenever you change your profile picture, whenever you change your username, then the HTTP server needs to tell the database कि please update Harkirat with this ID, this person's data. Their first name has changed from Harkirat to Halulu or whatever. And delete data if someone's deleting a post from LinkedIn or deleting their account completely is when the HTTP server would tell the database कि हाँ, get rid of this user, they want to delete this specific resource. This is popularly known as CRUD. Let's see the API for the Mongoose library. Eventually, we'll be using Prisma, which is the industry standard way of doing this. This is highly debatable what is industry standard here. But Prisma is the ORM that's used very commonly. Harkirat ORM, new technology you've introduced. Basically, the library to talk to a database. Prisma is the most popular one. Mongoose is, if you're dealing with MongoDB, Mongoose is maybe the best one right now. But you will see eventually, irrespective of what database we're dealing with, we will be using Prisma throughout, be it an SQL database or no SQL database. For now, we're using Prisma. For now we're using Mongoose. In Mongoose, first you have to define the schema. This is going to boggle some heads. Okay, Harkirat, you said database schemaless. Let me actually go to the iPad here because this is supposed to be confusing for a few reasons. Okay, when we discussed SQL and no SQL databases, I said that no SQL databases are schemaless. And now I'm saying that MongoDB, even though it is schemaless, Mongoose makes you define some schema. Why am I saying that? Let's go to the iPad for this. Oh, well, hello. Sorry, you're not going to see my face. There we go. So what did I say? That Mongoose made the first step is to define your schema. What do I mean by this? Firstly, MongoDB is schemaless. What does even schema mean in the first place? Schema means what is the structure of my data that I'm putting inside here. For example, I could be like, okay, I have users who look something like this. They have an email, they have a password, they have a first name, they have a city, and they have an age. These are the 5 things that my user needs to have. So this is my schema. Now some databases will tell you, okay, if you want to store data in me, you have to upfront tell me, okay, haan bhai, this is what the users table looks like. These are what are called SQL databases, structured query language. You have to upfront tell the database, okay, bhai, this is what the users table looks like. And the database will be like, okay, now you can send me some data. MongoDB is in stark contrast to this. MongoDB says, send me whatever you want. You can send me something that looks like this, ID or whatever. Sorry, not ID, maybe email, harkirat@gmail.com, and password something. And then in the next write request to the database, you can tell me username, Harkirat, and password something else. Database does not differentiate or does not discriminate. Jo bhejna hai bhejo. Send me whatever you want. Let me show you an example. We have done MongoDB a little bit. So hopefully you guys remember this UI, which was the MongoDB Compass UI. Let me connect to a database of my own, assuming it already exists. It does not. So there's a different one that I can connect to here. And in this database, let me create in this cluster, let me create a fresh database, or I have something called Kirat here already. If you look at users here, it has this field. It has one user with this username. Notice there's no first name, there's no last name. Let me add some data here. I'm going to add, ignore this OID ID field. Email harkirat22@gmail.com. First name, something random. Insert, not some error is here. Let's see. Let's try that one more time. Insert document, and let's add a random field here. Call it email, something random, and first name, something random. If I click on insert, you will see I have two documents, the schema of which is significantly different, completely different. This one has username field, this one has email field, this one has first name field. MongoDB lets you do this. SQL databases, when we come to them eventually, don't let you do this. Udhar agar this is username, this will also have to be username. You have to follow a strict schema. But MongoDB lets you define any sort of schema, does not matter. Okay? Now, given that MongoDB is this cool, it lets you define any sort of schema. Mongoose, the library, which is basically the library that you will import in your Express server, doesn't let you put anything in the database. It says, first tell me what is your schema. So you first have to tell me that users table looks something like this. First name, last name, so on and so forth. Once you tell me this, then you put whatever data you want into the database using some functions that I provide you. For example, user.create, where you can only give me first name and last name. Whatever schema you have defined first is what you will have to follow here. I will not let you put any random data in the MongoDB database. Harkirat, does that mean the database has suddenly become strict? No. The database, I can still insert random data into the database using this GUI library that you just saw, using MongoDB Compass. This guy does not differentiate, but your Express server specifically will not let you put anything outside of this schema that you've defined. If you've defined user schema looks like this, it won't let you put, a third random field or, anything random into the database. It will only let you follow this specific schema. That is the benefit of Mongoose. You might ask, Harkirat, how is this even a benefit? This was the benefit, Mongoose is very loosely typed and, very nice, lets you put anything. Sorry, MongoDB is very loosely typed, lets you put anything in there. You brought a library that is making it lose its appeal, its feature, which was you can put anything else here. I will say yes, you might think so. Mongoose is such an evil library, takes away all the benefits of MongoDB, but that's not true. This sounds counterintuitive since MongoDB is schemaless. That is true, but Mongoose makes you define schema for things like auto completions. Number one, not the biggest reason, but like the good reason for user, for you to define your schema up front is you get these auto suggestions inside VS Code. Since you've defined the schema up front, whenever you're writing your code, you will get suggestions like these. Bhai, I know user has a username field. Maybe this is what you mean. That is one benefit. Another benefit is validating data before it goes into the database. Make sure you're doing things right. You are a dumb developer. Everyone is a dumb developer. You might forget the field in the database, I totally forgot whether it's called username or email. So you might put something random here by mistake. Mongoose lets you avoid these mistakes. Generally you will have a strict schema only. Even though MongoDB lets you do whatever schema you want to put there, generally in your application you want a strict schema, which is why people prefer SQL. It lets you enforce strict schema. But MongoDB, since it does not let you do it, Mongoose is actually gives you a benefit and makes your application more strict. This is similar to the difference between TypeScript and JavaScript. Can you always suffice with JavaScript? Yes. What does TypeScript provide you? Some type safety on top of JavaScript. This seems counterintuitive. Okay, why do you need this? JavaScript was meant to be loosely typed. Why are you adding type safety here? But it is just, a benefit on top, which gives you longer term benefits. And similarly, Mongoose in the longer term will give you benefits for defining the schema up front. Schemaless databases can be very dangerous. Using schemas in Mongo makes it slightly less dangerous. What do I mean when I say dangerous? I mean you might put some random data in there by mistake, and schemaless Mongoose lets you avoid that by putting some strict schemas. Now let's understand how do you define a schema inside MongoDB. This is an important bit, especially this purchased courses bit right here. So bear with me for 5 seconds here. I say I have a course selling application. What do I have? I have a course selling application like Udemy. What would my database look like in that case? Harkirat, you will want to have a users table. Okay, this is a user who has this email and this password. Ignore this third bit for now. Email, password, user, simple, straightforward. This is the way to define your schema in MongoDB. What do? You say const user schema. Notice the capital U, just convention, equal to new mongoose.schema. This is what you've imported from the mongoose library. You've written a const mongoose equal to require mongoose at the top of your file. And then you say const user schema equal to this. Email is a string, password is a string. Ignore this third bit for now. That's how you define the user schema. And then you've defined a course schema. Okay, by course has a title and a price. It might have 10 different things. It might have a cover image. It might have a description. It might have a number of instructors. But for now, assume it's simple, straightforward this. Now that you have these two schemas, notice a third thing here. How would you store in the database? Okay, Harkirat has purchased these two courses. That's the interesting bit here that Mongoose or MongoDB provides you. Notice in the MongoDB Compass UI, I can create very nested objects. I can write, okay, bhai, name Harkirat, and then courses that this guy has is an array, which is maybe, an array of strings. Full stack course Harkirat has bought and Web3 course Harkirat has bought. If I click on insert here, you see name Harkirat and courses is an array. Can you see how MongoDB lets us create such complex objects? This is in stark difference to what SQL lets you do. SQL does not, or SQL databases like MySQL or Postgres don't let you put transitive nested objects like these. There is a way to do it, but a very ugly way. Generally, whenever you're creating a SQL database, you will have a table which has things like, username, password, age, first name, last name, and that's it. These all will be individual rows. Never will you see a complex object in here, but MongoDB lets you do it. So the way to create relationships in MongoDB, what do I mean when I say relationships? I mean things like this. Harkirat has bought these two courses. This is a relationship, right? Harkirat, who is a person, has bought these courses. This is what's called a relationship. And the way to create a relationship in MongoDB is by just, creating an array of the things that Harkirat has bought. This is different from how you would do it in an SQL database. But that is why we have this third field here. What does it say? It says that bhaiya, every user has an email and a password, and they have purchased courses, which is an array of type object ID. Now we'll see what that is. And ref course. Ref course is very important. This is what I mean when I say relationships. How will your data look like in the very end in this case? Let's look at that. You will have a users table, which has username, password, and maybe, first name. And you have a few entries here. Also will have an ID field. Let's say ID 1, name is Harkirat. Let me turn off suggestions here. Password is, let's say 123, and first name is Harkirat. Similarly, ID 2, ID 3, a few more users I have here. I will have another table called courses. ID, which is the course ID, title, and price. 5,000 rupees, title, whatever ID, whatever. 3,000 rupees, so on and so forth. Now, I have to create a relationship. I have to define, what all courses has Harkirat bought. I can do one of two things here. I can either create a new table, call it purchased underscore courses, and here I can store user ID and course ID. This is how you would usually do it in a SQL database. I'm creating a third table, calling it purchased courses, and this has ID 1, a few entries. This has ID 1, course ID 1, user ID 1, course ID 2. What does this mean? Harkirat has bought this course. Harkirat has bought this course. Whenever Harkirat goes to the website, hits your HTTP server, does a payment, you would put these entry in this database and in this table. And by the end, this is your schema, or this is one way you can structure your course selling app. 3 tables are good enough for me. A users table, a courses table, a purchased courses table. And the purchase courses table is nothing but a relationship between these two. By relationship, I mean who has bought what course. That's what's stored in this table. You might ask, Harkirat, why are we only storing IDs here? Why are we not storing the whole thing? Ki haan, user ID, course ID, name, course name, price, and everything. The answer is you don't have to, right? This is good enough. This is enough information to know who has bought what. User ID 1 has bought course ID 1. User ID 1 has bought course ID 2. Let's say in the future, user ID 2 has also bought course ID 1, so on and so forth. This is enough information for you to know or prove कि हाँ, Harkirat has bought this course. Cool. All right, let's proceed. That's one way of doing it. What is the other way of doing it? Okay, you use this NoSQL property. You say okay, a user table will be username, password, and purchased courses, which is an array of references to another table, which is the course table. What is this reference? It basically means that by this points to something here. You can just store the ID of that thing here, and then eventually you know that this thing actually exists here. So purchased courses, I'm going to create as an array of individual courses. Very similar to what I was doing here. What did I say? Name Harkirat, courses are, Harkirat has these two courses. Only rather than them being strings, I'm going to have them as references to another table here, which will be called courses. So I'll have another courses table. I'll have a bunch of courses here, and every user will have username, password, and a third key here called purchased courses, which is an array of all the individual courses that this user has bought. And in MongoDB, this is how you define that in the schema. As you can see, charge is very low. So going to take a 30-second break here. Try to breathe this in while I charge my laptop. All right. So how do I define my schema now? Email, password, and purchased courses, which is an array of type mongoose.schema.types.objectId. Now this might feel a little weird. Let me get to this very soon. But ref course, I hope you understand this. Ki haan bhai, finally, when I create objects from these schemas, I say कि भाई user table, user schema points to user table, course schema points to course table. These strings are what you see here in MongoDB Compass. कि हाँ भाई, there's a user table and a course table. Let's say right now they're courses and users. So this is not right. But eventually when MongoDB creates them, it will create a user table here and a course table here. If I say कि हाँ भाई, mongoose.model user is what points to the schema, course is what points to the schema. And lastly, purchased courses, there's this thing called object ID. What is this? You will notice whenever I'm creating a new field here, the randomly generated ID for that is something called object ID. This is just a MongoDB way to create randomized IDs. Okay, whenever you add some data, if you saw anytime I was adding some data, there was a random ID here. This is what's called an object ID, which is a randomly generated ID. And purchased courses will have what? It will have an ID or, a reference to course schema, which basically means it will be storing, let's say there is a course here. And, the title is full stack course and the price is 5999, insert. This is the object ID for it, or like the ID for it, the unique way to identify it. And in your users table, you would not have an array of strings. You would actually have an array of these object IDs. That is generally how your final schema would look like for a course selling app. And this is the way to define that in Mongoose. Cool. Feel free to take a pause here. Eventually, when we start to put data in the database using Mongoose, this might become slightly clear if this isn't already. All right, let's look at the syntax of Mongoose to actually insert data in the database. You've defined the schema this way. You've defined the model this way. These are the two things we already defined in the last slide. Of course, this had an extra thing, but let's keep things simple for now. User schema is username, password. And this is how you create the model for it. What is the model, Harkirat? This is the final object on which you can call .create, .update, .delete. That lets you do the CRUD operations on the database. So in your final application, whenever a user sends in a request to sign up, this is the request that this is the function that you'll be calling user.create, username with this username, password with this password, and this will put in your database an entry in the users table. This is the syntax for it. And similarly, very similar syntax for reading user.find by ID lets you find something by an ID. Of course, this will be a very long object ID and not, something like 1, 2, 3, but you get the idea. User.find find one entry with this username or find multiple entries with this username. That's the difference between user.find1 and user.find. You'll notice there are a bunch of these, finds that you can do. In fact, if I go very quickly to the assignment from this week, and since I'm on Visual Studio Code, wherever this schema is defined, which I think is this thing right here, I can actually, see some autocomplete. User.find by ID and delete, find by ID and update, find one and delete, find one and replace, so on and so forth. So there are a few functions that you can call on this users model. You can look at all of them if you want in your MongoDB, in your VS Code here. You can try typing update and it will show you update many, update one, find one and update, so on and so forth. So you can actually explore this yourself, but high level I've tried to put a few of them here. And notice this one, user.update1, where ID is 1, push purchased courses course ID. If you want to add a new entry to the purchased courses, if someone actually buys a course in your database, in your application, you want to push a new course here, this is the syntax to do it. You would say user.update1 for the user with this ID, push to their purchased courses this specific course ID. We will see this very soon when we get to our assignment. Update, user.update1. I showed this to you, pretty simple stuff. If you want to update the whole thing, you call .update. If you want to update just one entry, then you call update1. Even if there are multiple entries that match this, it will just update the first entry. If there are multiple entries that match this, here as you can see, it is an empty filter, which means for every row in the table, make this update set premium to true. Let's say you want to give free access to your people, for everyone to your courses, and then let's say premium true is the field that represents that. If you call this query, everyone in your database gets free access to your courses. Delete many and delete one. This lets you delete everything from your database. So don't call this ever, else you're basically deleting everything from your users table. And this lets you delete one where, let's say, this looks wrong. I think the first argument would be username Harkirat, and here as you can see, the first argument is empty. Probably that's not right. Let's see. User.delete one. And as you can see, it says filter is the first option, which in our case is username is Harkirat. So this is the right thing. Let me actually replace this in the slides as well. Oh, well, I guess I can just override. There we go. Cool. That's how you do CRUD in the real world. These are enough APIs that you know on this model to be able to put data, delete data, so on and so forth. Now, 3 jargons you need to know in database. This is the other thing you need to know other than CRUD. When you create a database, when you go to mongodb.com, when I was in, Compass here, what are all these things here that I see? What is a cluster? What is a database? What is a table or a collection? 3 jargons you need to know of. A cluster basically is that you have bought a machine, an AWS machine, jahan pe you can run multiple databases. You can put multiple tables inside a database. A database is that if you have one application, for example, I might have a course selling application, I might have an e-commerce application, I might have a social network. Each one of them will usually have a separate database. This is the database for doing one thing. For example, here you see I have an admin database for doing some admin stuff. I have a certificate database. This actually powers one of our certificate websites for the cohort one. I have a Kirath database for testing things out. Every application has its own database, and inside every database, there are multiple tables. For this application, a course selling application, you need 2 tables. For another application, you might need 10 tables, so on and so forth. So Cluster, database, table are the three high level jargon you need to know of before you proceed. Cool. And for something like a course selling application, something like Udemy, you can structure it a few ways. As I said, either you can store the purchases directly in the users table, or you can create a separate purchases table which has a user ID and a course ID. This user has purchased this specific course. If you take the second approach of having a purchases table, this is what your table would look like, or your database would look like. You would have 4 tables: a users table, an admins table, a courses table, and a purchases table. You would get rid of the purchases table if you're storing them directly in users. It really depends on how you want to structure your application. But let's say you want to structure it this way. Okay, purchases is a separate table and you don't store it directly in the users table like we did a few slides ago. Right here. Here we are storing it directly in the users table. Here, this is a new way to describe the schema. You can pick and choose whatever you want. This is a more SQL way of doing it. Cool. ठीक है जी. Users table would look something like this. In this case, there is no need for storing purchased courses here. We have a separate table that stores them. ID, password, name, age, whatever you want to store. Admins. What is admins? In a course selling application, you would generally have admins. For example, our 100x Steps website, I am one of the admins. Rookie is one of the admins. We can put data there. We can upload videos there. We can change the titles of videos, things like these. So you also need, another table called the admins table. You can actually do this in the same table and have like an is admin key there. Really depends on how you want to structure your application, but you could also, have a third key here, call it is admin, and have it true for admins, have it false for people who are not admins. Depends on how you want to structure your application. I want to create a separate admins table. So that's what I've done here. Courses, which is ID, title, description, price, and purchases. This, if you notice, what all does it have? It has user ID, course ID, which means user 1 has bought course 1. This is the time that they bought it on, and maybe a reference to, an external provider. Usually payments are not done in-house. You use something like Razorpay or Stripe to do them. And when you're doing that payment, whenever that user has done that payment, you store a reference to it so that when you want to in the future want to go to razorpay.com and look at all the purchases for that user, or the purchase that led to this specific course being bought, you can see it there. You can see their UPI information, things like these. Cool. This is how a course selling application schema would look like if you're doing it this way, where you're storing purchases separately. Now let's target the assignments from this week. The assignment from this week is basically this: a course selling application where you have admins, users, and courses and purchases. We are not going to do it this way. We are not going to have 4 tables. We're going to have only 3 tables. And in those 3 tables, I'm going to, store user information, admin information, courses information, and the purchases information will be stored here. Admins would be allowed to put data in the courses table. We will see how all of this happens when we reach the assignment. Let's try to target the assignment from this week. So at this point, I would urge you to take a breather. Hopefully you understand high level schema, models, creates, finds or reads, updates, and deletes. If you understand the syntax a little bit, your life is about to be sorted when you try to target the assignment for this week. Let's open the assignment for this week in VS Code and go from there. Alright guys, let's get to the week 3 assignments. There are 2 assignments to go through: O3 Mongo and O4 Mongo with JWT authentication. Let's start with the first one, O3 Mongo. If you go to the README here, it says you need to implement a course selling application. Make sure you set up your own MongoDB instance before starting. So even before we touch anything, let's do this and create a MongoDB instance of our own. Some of you might have already done this. The ones that haven't done it, I'm going to redo it in front of you right now. After you sign up on mongodb.com, you will reach this page where it will ask you to create an instance. Create a free M0 instance for learning and exploring MongoDB. Select any region you want, select any provider you want, and then finally click on create here. Once you do, you reach this page where it asks you to create a username and password. This is my username. I'm going to store it right here. This is my password. I'm going to store it in this file right next to it, like in this URL bar. Make sure you've secured these two somewhere and click on create user. Here, add this specific IP 0.0.0.0/0 and write a description for it. I'm writing everywhere. You can write whatever you want. This basically means who can access your MongoDB instance. As you can see, it has one IP here already, and it says my IP address. This is actually my Delhi IP address. If I search for what's my public IP, you will notice my public IP is this 122.162, so on and so forth. My location is currently Delhi. I'm using an Airtel as my ISP provider. MongoDB automatically adds you so that you can, test your database, but generally your IP keeps changing. So it's a good idea to add this here so that your database is accessible from anywhere. Even if I go to Chandigarh now, I can still access my database. In production, in the real world, you restrict these IPs, but for now, just open it up to the world. Finish and close. Now, as you can see, you have a basic database created. Click on connect here, select Compass, and based on whether or not you already have MongoDB Compass, select download it if need be. If not, just copy this string and replace password with your password that you created while you were creating the user. For me, it was this right here. So I'm going to copy it, paste it here, and go to MongoDB Compass. I'm going to reopen it. If you haven't already, first install Compass. It's an application that lets you connect to your database and visualize it, put data inside. Paste it here, connect. And as you can see, I am connected to my cluster. What were the three things we discussed? We said a database has three parts: a cluster, a database, and a table. I am connected to my cluster. I have two databases already. I can create a third one here, call it courses, and create like a random collection inside or a table inside. So now I have a courses database which has a courses collection or table. You can call it whatever you want. How many do we need for our app? We need 3 or 4 based on what kind of schema you're creating, whether you're creating users, admins, courses, purchases, or whether you're simply creating users, admins, and courses, and the purchases are going to be part of the user schema. Based on that, you need to add more here. For now, don't worry about it because MongoDB will automatically create these for you, not MongoDB, Mongoose will, when we write the code. So feel free to just make sure you're connected here. And once you are done with the first part of the assignment, which says, okay, you need an instance before you start. This is my instance IP, or like a way for me to connect to my instance. Take a pause here, make sure you have this URL, and then proceed. It needs to support 2 types of users, admins and users. Admins are allowed to sign up and create courses. Users are allowed to sign up, view courses, and purchase courses. This in the real world would translate to an app like Udemy. This doesn't use authentication the right way. We will learn how to do that in the next assignment. So there is a O4 Mongo with JWT auth assignment where we'll do it the perfect way. For now, for this one, in every authenticated request, you need to send the username and password in the header, not the JWT, just the username and password in the header. So even if you don't understand JWTs, you'll be able to get through this assignment, but you won't be able to get through the next assignment. This is the reason why this assignment doesn't have a sign-in route. If you look at the routes that this specific assignment wants you to create, it is a sign-up route, a route to create courses, a route to view all your courses. It does not have a route to sign in, which is something you will see in any website. If you go to chat.openai.com right now, there is a route to sign up, there is a route to sign in. But since we are not using authentication the right way, there is no need for us to have a sign-in endpoint here. The goal of a sign-in endpoint is to return you a JWT or a token. We are not doing any authentication. We are not doing any JWT logic here, which is why we're just going to create the sign-up route, courses route to create a course and get all the courses for the admin. And we have a few user-specific routes. A user can sign up. A user can view all the current courses available on the website. A user can send a post request to purchase a specific course, and then a user can get all their purchased courses, that basically the ones that they've sent a post request like this on, they should get back when they try to hit this endpoint. Just a place for you to see all the courses that you have purchased. Cool. There is also like the schema, the input, the output that's already been written here, which basically means if you copy this over and paste it to ChatGPT, it'll give you the answer. But let's try to build it ourselves. In fact, you will see I've already written some boilerplate code. What does boilerplate code mean? It means I've written some basic handlers. You just have to write the logic. The skeleton of the app has already been written. If you look at it, there is a top level index.js file, which is very small. Until now, we have seen very big index.js files. But in this assignment, I have structured it very well. I have put things inside various folders and files and imported them rather than putting everything in a same file. This is generally a good practice. Okay, you shouldn't shove everything in a single file. You should have some sort of a file structure, which we have over here. I say there is a DB folder which has an index.js file, which if you look at it, it defines your schemas. It has an admin schema, a user schema, a course schema, and then an admin model, user model, course model, and it exports these three. These are all your database things that you need for this application. Basically, users, admins, and courses table. We are going to shove purchases inside users, which is why I did not have to create a fourth one. These three are good enough. And I've already created the structure. You just have to define the real schema. Ki haan bhai, username needs to be string, so on and so forth. That's the MongoDB file. And notice it exports things at the bottom, because it's like I'm going to write all the database logic here and going to export it. Whoever wants to use it, feel free to import these and call whatever, admin.create, admin.update, so on and so forth. The second folder here is middleware. There are two files here, the admin.js file, user.js file. Again, this one is creating a admin middleware. It says implement admin authentication logic here. You need to check the headers and validate the admin from the admin database. Check the readme for exact headers to be expected. So what is this admin middleware and user middleware? If you look at the readme, it says ki haan bhai, after you sign up, if you want to get all the courses, you need to send a username and a password to be able to get back all the courses. If someone is not signed up on the platform already, they shouldn't be able to access the courses. And similarly, for an admin, after you have signed up as an admin, if you want to create a new course, in the headers, you need to send the username and password that you used to sign up on this platform as an admin. Only if you use the same username and password will you be given this output, else you will be given some, 404, you will be told that you don't have access to this resource. Maybe most probably you'll be given a 403 status code. Depends on you, however you want to implement it. And even if you want to get all the courses, the user will need to send, or the admin will need to send the username and password in the headers when they're sending a request. These middlewares need to do that validation logic. So it will be something like const username equal to rec.headers.username. Same for password, and then it will need to hit the database, check if this admin exists in the database with the given username and password. So we have to write all of that logic in here. We will get to it soon. DB folder done, middleware folder done. Routes folder. This one is interesting. Look at it. What does it say? It says const router equal to new router, router.post/signup, and a function where the control would reach whenever the signup endpoint is hit. Similarly, one for courses and one for post for courses to create a course, get for courses to get the courses. Notice I've already put ke haan bhai, these two are protected by the admin middleware. Of course, the admin middleware does nothing right now. We will write logic here, but I've created the structure. Ke haan, this and this need to be protected. This route is open to everyone in the world. Similarly, for user as well. This might feel a little new. Ki abhi tak to hakikat we were doing this. Const express equal to app, and then app.get, app.post, so on and so forth. Here, Harkirat, you are doing const router equal to router and router.get router.post. Why are you doing this? Great question. This is one way of structuring an Express app. If you look at the top level file, what have I done here? I've said, okay, import Express, import body parser, const app equal to Express, app.use this, and then I've said app.use /admin, admin router. This is a new way for us to use app.use. What did we know until now? Okay, bhai, app.use is anytime we write this, whatever is the middleware that's being passed here is what will first get called before any route gets called after that. Now we are saying app.use. First we are passing a string. and then we're passing this. What does this mean? This means that anytime a request comes to /admin /anything, does not matter what, it will go to this router. And what is the admin router? It is a fresh router, which is something that Express exports. And if this feels confusing, you can also do something like this. It's basically a way for you to structure your application better. Okay, bhai, all the admin requests, please go here. All the user requests, please go here. And now if any request comes to /admin /signup, the control would reach here. If any request comes to /admin /courses, control will reach here, so on and so forth. I repeat, just because I've written router.post signup does not mean this handles the /signup endpoint. It handles /admin /signup. Harkirat, you haven't written /admin /signup here. How does this handle the request to /admin /signup? It is because in the main file, I have said any request that's coming to /admin, go here. And here I say anything after /admin /signup /courses is what these guys handle. Cool. This is just a better way to structure your Express application. Nothing new, nothing. You could totally still, do app.get /admin /signup here. And you don't have to, do everything I've done here. You don't have to structure your file better, but it's generally good practice to, have all your routes in a different folder, have all the database logic in a different folder, have all the middlewares in the different folder. But in the end, you're just, again, calling code or routing requests to various handlers. Cool. Feel free to take a pause. I haven't written any code yet. Feel free to explore the application. Maybe try to run it locally. For that, make sure you're in the 03-Mongo folder. Run npm install and run npm run dev. Sorry, not npm run dev. Run node index.js. And once you do, it says server running on port 3000. Try to send a request to localhost :3000. You will see it says cannot get /. This is the standard error that you get if a route handler hasn't been defined. But if I go to /admin /signup, it says cannot get /admin /signup /admin /signup. Oh, because it is a post. Let me go to /admin /courses. And you will see the request is hung. Why is it hung, Harkirat? Because I haven't written anything here. I haven't yet written rest.json message hi there. But if I do write this and if I restart and if I go here, node index.js, is this the right file? Go to week 3, looks right. Refresh, still does not work. Why does it still not work? Console.log, hi there. Something obvious I'm missing here. Get /courses. Oh, admin middleware doesn't do anything right now, right? Let me remove the admin middleware and then run it. And it says message hi there. Okay. So I hope at a high level, you understand how is request routing happening right now? How have I structured my application so that any request that's coming to /admin /courses is reaching here? Now we have to write the meat of the logic, which was the assignment. Ki haan bhai, actually do a mongodb.create, a mongodb.get in all of these places. So you have a well-functioning app by the end of it. Cool. Let's start. What is the first endpoint that is asked for us to create? It says create the /admin /signup endpoint, which creates a new admin account. Input body is going to be this. Output needs to be this. And we need to, of course, store this user in the MongoDB database. So firstly, let's define our schemas. Let's go to db/index.js and start to define our schemas. For admin, it is going to be a username, which is going to be a string, password, which is going to be a string. For user, same thing, a username string, a password string, and a purchased courses, which is an array of type mongoose dot types dot what was it, types dot object id, something like that. Let's see, this is where you either use Google or go back to the slides. Mongoose dot schema dot types dot object id. And what does it refer to? It refers to the course table right here, so something like this. And lastly, the course schema, which is going to be maybe a title. It's probably written in the README, so let's read it out. How do you create a course? What do you send in? A course title, description, price, and image link. So 4 things it needs to support: a title, description, image link, and price, which is could be number, could be string. Let's make it number. Cool. At least one file is done. I have finished the db/index.js file. I also need to replace the MongoDB URL here. So let's do that. I created this database right here. So let me copy it over and paste it here. If you have done this, you are done with the first part of this assignment. You have created the schemas correctly. The only confusing bit, this thing right here, we will see later on as we implement the /user/courses endpoint, which is this endpoint right here, /user/purchased courses, how this comes into the picture, how the API for, referring a course given a user happens. Cool. All right. Middleware is next. Let's try to implement the middleware. What does the user need to send? User needs to send the username in the header and password. If this feels confusing right now, it'll get better as we start to actually go into Postman and sending these requests. I have username and password. I need to check, does this username actually exist in the admin database? So what do I need to do? Number one, I need to get the admin model here at the top. Const admin equal to require /db. If you want, you can also write db/index. Both of them work. If you don't write index, it is assumed you want to access db/index. And what do I have to do? I have to check, does this user exist? So what can I do? I can say admin.find1 where the username is this username and password is this password. This is the variable. For example, this might be 1 2 3 4 5 6 and this might be something like harkirat@gmail.com. Here we are checking, does this exist in the database? And if it does, again, if you want, you can use async await syntax here. I'm using the .then syntax. I'll maybe quickly show. Oh, well, yeah, we can use the async await syntax here as well. .then value. If value does exist, what does that mean? That means you found a user who has this username and password, which means what? You can call next. You can say, okay, bhai, whoever was calling this admin middleware, this user, when they were sending this request to you, let's say, where is this admin middleware used? It is used in routes/admin.js right here. Whenever someone is trying to create a course, if their username and password, there is a user that exists in the database with that specific username and password, you call next, which basically means let the control reach here, let the control reach here. But if they don't exist, if there is no value, which means there was no value that was found, it could not find one user with this username and password, means either there is no user with this username or whoever is the user with this username does not have this password. So that means you can stop the request right here. You can send rest.status403.json message user doesn't exist. Is this part clear? I hope it is. It is just creating the middleware, assuming of course a few signups have already happened, right? If no signups have happened, then this will always return you null, which makes sense. If no admin has signed up on your website, they shouldn't be able to access this endpoint or this endpoint. But as signups happen, you have more and more admins. This logic will check whether or not they exist. And if they do, let the control flow through. If not, return to the user, okay, bhai, stop. You're not yet allowed to access a resource because you're not an admin. Cool. Similarly, can you guess what the user middleware will be? It will be almost exactly the same, only rather than checking the admin database, it needs to check the user database. That is the only difference between the user middleware and the admin middleware. Because effectively, it's just usernames and passwords stored in various tables. If you look at the MongoDB eventually it will have a users table here. It will have an admin table here. And this will have some usernames and passwords. This will have some usernames and password. The right middleware needs to hit the right database. Ki haan, user middleware needs to check, is there a user entry here with this username and password? The admin middleware needs to check, is there a admin entry here with this username and password? And based on whether there is or not there is, needs to let the control flow through or stop the request right here. This should say user does not exist. Ideally, admin.js should say, is it admin.js should say admin does not exist. Cool. We're done with DB. We're done with middleware. Only thing that's left now is implementing the admin routes and the user routes. Let's start with the admin routes. What does /signup need to do? Number one, get the username. How do I know all of this? If you go to README, it's written /admin/signup. This is the input that you expect from the user in the body. So I can simply say rec.body.username here. Password is rec.body.password. Now what do I have to do? I should do a few checks ideally. I should check if a user with this username already exists. And if they do, then I should say user has already signed up. Stop the request. If they do not exist is when I should put something in the database. Cool. For now, let me just create it. Let's assume no one sends requests twice with the same username. So what do I have to do? I have to do admin. Again, I imported admin from /db here. Admin.create username, this username, password, this password. You don't really need to write this like this. If you know a key of something, the variable in which its value is stored is the same as this key, you can actually just write this as well. Does the same thing. This and this both do the same thing, but if you don't understand it, it's fine. You can leave it as is. Admin.create. Ideally, you should wait for this to resolve, which means make sure that the entry actually happened. There was no network connection interruption or anything like that. And only if .then gets called should you return to the end user ki haan, you are okay. The user has been made. But for now, I'm just going to assume this just works. It will work in like a second, might take some time. I'm basically not awaiting on this database insert. I'm simply telling the user, what is the message I need to tell them? If I go back to the README, it is message admin created successfully. So I'm just simply going to tell them admin created successfully. What should I ideally do? I should await for this. So I should do this. Only if the user is created should I return this. And I should have a catch here, which I'm unsure if I've introduced this, but basically if there is an error in this creation, then the catch will get called, and here you can return user not created or admin not created. Cool. You can also do, the async await syntax, in which case this becomes async, and you can await for the user to be created. And only if the user is created will the control reach here. If this throws an exception, it'll just stop right here and the control would never reach here. The user will see a 500 status code. Cool. Looks decent. Simple async await syntax, clean syntax to allow the user to sign up. Let's see if it works. Let's take a checkpoint here and start our application. Node index.js. Let me hit the /admin/signup endpoint. So I'm going to go to Postman for this. And here I'm going to select a post request to localhost :3000/admin/signup. Body, I'm going to send username and a password. If I click on send, it says admin created successfully. How do I know an admin is actually created? Is I can go to MongoDB Compass, refresh, and check the admin. There you go. A test table has been created. A test database has been created, which has, as you can see, the admins table, courses table, and users table. Harkirat, how did test get created? Why did courses not get selected? Well, if you go back to our MongoDB URL, what does it say? This thing, test. It seems like this is the default database that Mongo might create, or I've mentioned test anywhere. If I want to specify the database that will be used, I can write it here. I can write course underscore selling underscore app. And now if I refresh this and go here, you see course selling app. This is the database that has been selected. And now let me put some entries here. Let me go to Postman, send the /admin/signup request with this username and this password. And if you look at admins here, I have a username Harkirat, password 123. Does that mean we have created one part of our full stack application? Yes, we have now implemented the sign up endpoint. If I ever create a website and give a form that looks something like this, username, password, and sign up, then this is the endpoint that will hit. Of course, in the real world, people ask for phone numbers, people ask for age, date of birth. We have kept it very lean right now. But if you want to add more fields, you totally can, right? You can ask the user for first name, and then, in your handler, in your schema, define first name here as well. And then in your handler, do a admin.create username, password, and first name as well. So it depends on how complex of an object you want to store for the admin. For us, for now, this is good enough. This endpoint seems to do what it's supposed to do. Now let's go to app router.post/courses. Let's go to README and see what implementation it expects from us. It says /admin/courses. The user needs to send some headers with their username and password. This is the same username and same password that an admin has been created with in the past. Now our MongoDB database does have one admin. So whoever is hitting this endpoint needs to send in either these credentials, or if there are more admins, they can send the credentials of those admins. High level is they need to send this. That is what this specific route will support. If you don't send this, it will not work. And we have already written this logic in the admin middleware. The body is 4 things we expect from the user: title, description, price, and image link. We've already defined this in our database schema. Let's write the handler for this in route/admin.js. So what are the first 4 things we expect? Const title equal to rec.body.title, description, image link, and price. Ideally, you should use some library like Zod here to do input validation, because user can send you anything they want. So make sure in the real world, you're actually doing some input validation before you proceed. Now, what do I need to do? Pretty simple. Course, again, make sure you import it from the top, from /db, course.create, title, description, image link, and then price. Again, you can write this if you want, or you can just, if you know the key and the value are the same, you can just do this. Both do the exact same thing. Also, again, if you want to await this, feel free to await it. If you don't want to await it, that's fine as well. Just return to the user JSON message. What is the message that the README expects us to send? Course created successfully. And notice, it also expects you to send back the course ID. So it's not going to be as simple as this. How do I know the ID of the newly created course? This is where you actually have to await for the entry to happen. In MongoDB, whenever you put some data, an ID is generated randomly and given to that data. For example, if I go to MongoDB Compass here, you see I only said username and password, and ID was created randomly. So whenever you put something, you get back the ID. Question is, how do I get this ID here and put it here? And the answer is, again, depending on what syntax you're using, the .then syntax or the async await syntax. I'm going to use the async await syntax. I can do const new course equal to await course.create, and then I can do new course _id, because this new course object, let me log it, and you can see what this new course object would be, and ._id is the ID of the newly created course, similar to how the _id here represents the ID for this newly created admin. If I restart, 1 second. If I restart this and go back to Postman, let me send a request to /admin/courses. What is the first thing I need to do? Add the authentication headers. So go to header and send in username harkirat@gmail.com, password 123. If you don't send this, your admin middleware, what gets hit before the route gets hit? The admin middleware. And what does it check? Is there a username in the header? Is there a password in the header? Is there an admin that exists with this username and password? Only if it does it let the control reach here. So make sure you are sending username and password, and also try to send wrong username and passwords, and make sure your route request gets blocked. What are the 4 things I need to send for this /course endpoint? Title, let's call it full stack course. Description, 100x devs full stack course. Image link, this would be some link to a URL. I'm going to write a random one, cat.png, and then lastly price, which is, let's say, 5999. Post request to /admin/courses with the username and password in the header and body as being this. If I click on send, it says course created successfully and gives me back a course ID. If I go to MongoDB, look at the courses table. What does it say? Full stack course, 100x devs full stack course, image link, and a price. Are we slowly getting there? Have we almost completed the admin functionalities? Have we created a way for user to create multiple courses? If I write Web3 course here, new Web3 ETH course, and write whatever 1999 here. If I click on send, says create course created successfully. If I refresh this, I see 2 courses. If I look at this ID, that is the exact ID that is stored here in the database as well. And if you look at the logs, you will see I was logging whatever this entry would, or this function call would return me. And as you can see, it returns me the whole object that has been put in the database along with the ID. I only sent in title, description, image link, and price. This is an automatically generated ID. This is what the MongoDB request sort of returns you back, and you get it here. And that is how I was able to send to the end user new course._id. Cool. ठीक है जी. Done with this post. What else is left? The third endpoint. What is the third endpoint here? It is router.get/courses. Basically return the user all of their courses. Can you try this yourself? It's very simple. It's basically const all courses equal to, again, make sure this is an async function, or use the promise syntax, whatever you want. Let me use the promise syntax here, so it's slightly easier for other set of people who want to use the promise syntax. What do I have to do? Find. Do I need to pass in a condition? No, I want all the courses. If I wanted a course which has a certain price, I could have sent something like this. You give me all the courses with this price, but I want literally all the courses that the admins have put in the database. So I can simply do this. Response, and then send back res.json courses, and then the response. This is one way of doing it. What is the better way of doing it? That you create an async function and you await this call, and you do const response equal to this, and then you do this. This is, as you can see, less indentation, much more cleaner. Both of them will do the same thing. Again, I did not have to write any authentication logic here. That is already taken care of by the admin middleware. I just have to write the final logic, which is this right here. If I save this, if I refresh, if I go to Postman, and if I send a GET request now, because this is the GET request handler on /courses with the right headers, I get back both of my courses, course 1, course 2. Harkirat, what is the use of this endpoint? Well, if you go to udemy.com, and if you've ever created a course there is a page where an admin can see all the courses that they have, right? So this endpoint will be used on that page where the user will see all of their currently created courses. Cool. Now in the real world, you probably need a put handler here, router.put, that lets the user update their courses. Let's say I want to update the price of my course. In the real world, you have coupon codes where user there'll be another endpoint that creates the coupon code. Things like these. So there's no end to how much complexity you can add to your app, but this is a great start. Cool. Sign up endpoint. Post endpoint to create a course. Get endpoint to get back a course. The one thing that we haven't yet tested, let's test that a little bit. Let me open the terminal here. Let me send a wrong input, username and password. And you will see it says admin doesn't exist, which means our middleware is also doing the right thing. It is preventing a non-admin from putting any data inside. So there is only one admin in the database right now, right? And only that admin should be allowed to put data or, get back these courses. And that is why we expect the user to send back username and password. And that is how the authentication works. Is this how authentication works in the real world? Not really. It works using JWTs or some sort of tokens, which we will get to in the next assignment. Great. Seems like everything is fine. Seems like we have created the first set of handlers. Let's create the second set of handlers, the user.js file. Now this part, you should target yourself 100%. If you've understood the first part, this part should be straightforward. What does this guy need to do? Get the username, rec.body.username, get the password, and then store it in which table now? The user table, because we are now creating all the users for this specific application, not admins. So user.create username, password. Again, you can write username, you can write just username, both do the same thing. And then rest.json message user created successfully. Pretty straightforward. I'm not even going to test it. It'll just work. We'll, test it together. Implement listing all the course logic. Now this is the question, right? When someone goes to udemy.com, they don't necessarily need to be signed in. This can be an open endpoint where you can see all the currently present courses on the website. So this endpoint, as you can see, there is no user middleware here because this is open to the world. Anyone can hit it. All you have to do is return all the currently present courses, which, well, we have already done. If you remember, what was this endpoint? It was basically getting all the currently present courses and returning them. You might ask, Harkirat, what was the point of protecting this endpoint? If this other endpoint is doing the exact same thing and this one is not protected? Great question. In the real world, you will usually have one more field here in courses called, is published, which basically means whether or not this course is available to, the world to see, which will be either true or false. And when you have this specific field, you will basically filter. The user will only see the courses that are published. So that is why, you write the same logic in two places. And that is why it makes sense to, protect this logic, because this will show all the courses, but this will only show the published courses. Now we don't have that logic yet, which is why we do the same thing, but you get the idea. Cool. This is the endpoint to get all the courses. Now this is the first protected endpoint. Implement the course purchase logic. Ab yahan, this is the most difficult bit, because this is not as simple as doing, purchases dot create a user ID and a course ID. This would have been nice, but unfortunately we did not follow that route, right? I said, okay, we can do this two ways. We can either have a user table, admin table, courses table, and a purchases table. If we had the purchases table, then all I had to do here was this. All I had to do here was somehow do a get from the purchases table and get back the course IDs and return to the user. But we took a different route. What was the route we took? We said, okay, bhai, the database only has three tables, and this table has a reference, an array of references to the courses table. Now this is where we need to sort of insert things in this purchased courses array for this user, which also isn't too difficult. We actually have seen this a few slides ago. If you go here, what did I say? User.update1, where ID is this, push this to the purchased courses array, this course ID. So this isn't too difficult actually. What do you have to do? You have to get back the course ID that the user wants to buy, which if you look at the request in the README, what request is the user sending? They're sending a /user/courses/ course ID, which means this is the course ID that they're trying to buy. Harkirat, why are you sending a request like this /user/courses/1? Why are you not doing /user/courses with the course ID being in the body? no reason. I just wanted, you guys to also figure out this part. How do you extract a specific parameter from the URL? You can totally do this, whatever you want. The assignment says you need to support this, which is why I am going to get the course ID from the parameters, which is as simple as rec.params dot whatever name you've given here, which my case is course ID. I can give it, something else. I can give it a name of ID, and then this is how I will get that ID. Does not matter. In the end, whatever is the dynamic argument here is what comes here. Now that you have a course ID, what will you do? You need to push to the purchased array for this user ki haan bhai, something has been bought. How will you do that? You will first get their username, which if this has passed, which means their username is present in the header. So I can do this. I have the username. What do I have to do now? User.update1, where the username is this, and I want to the purchased courses. As you can see, beautiful how it gives you suggestions because we have defined the schema up front. I need to push this course ID, and that's it. This much was enough for me to update the user object here in the MongoDB database. And for a user, add a purchase course. We will see this very soon. Let's test this much. We'll get to this endpoint soon. This is pretty simple to implement. Let's try to see if we've been able to implement the first 3 endpoints correctly. Let's restart the process. I should probably return here rest.json message purchase complete. Let me restart this. And now let me go to Postman, start with the /user/signup request, username harkirat1@gmail.com, password 123. I have to make it a post request. User created successfully. If I go to MongoDB, refresh the users table, I see the entry for this user. Let me update my headers with this user right here. You might ask, Harkirat, you were sending the wrong headers. How did this work? Well, this request completely ignores the headers, right? This first request /user/signup doesn't really hit any middlewares. The user middleware does not hit. For that reason, ignores the header. You send whatever you want. All right. Updated the username and password. Now, request to get courses. Again, for this one, we don't really need the headers. And it returns you nothing. It throws an exception actually. So we will see. Oh, I have not imported courses most probably at the top. So let me do that. And now let me restart. Get request gives me back the current set of courses. Let me send the wrong credentials in the headers. Still gives me back the same thing because this endpoint, the get endpoint, isn't protected. If I do protect it, then this will not work with the wrong credentials. But since we don't need to protect it for now, it just works. Lastly, /course/course ID to purchase a course. This will be the fun bit. This is the new bit. This has the complicated syntax of to the purchased courses, push a specific course ID, do some sort of referencing that we sort of saw in the beginning of the video. So let's see if this works. What is the ID of my courses? Let's say the full stack course has this ID. What request do I need to send? /user/courses/ the ID of the course that I want to buy. And it needs to be a post request. So let me make this a post request. Now, what am I doing with this user's credentials? harkirat1@gmail.com 123. Who is this user? This user right here in the users table. With these credentials, I'm saying buy this course. Of course, in the real world, you do some banking stuff. You hit a Razorpay API, a Stripe API, make the payment, and then purchase the course. For now, we have some dummy logic to do it. If I click on send, it says user doesn't exist. Beautiful. Why does the user not exist? Let's go to our middleware, user.js, user.find1 with this username and this password. Let's return. Looks right. Maybe I'm sending the wrong username and password. Let's see. harkirat1@gmail.com. What is the current user here? harkirat1@gmail.com. Oh, there is no password here. Why? Because when I am implementing the sign up post/signup, username, password. I probably forgot to send the password or send the wrong password. Oh yeah, my spelling here was incorrect when I was creating the user. So let me create another user, harkirath2@gmail.com with a password. Now if I look at MongoDB, I have another user. Oh, sorry, wrong request. Post request to /user/signup with this body. And it says user created successfully. And now in the header, let me update this to Harkirath2, for whom a password does exist here. Username, password. I can also just, add a password here if I want. I can just be like, edit, and then, add a new field here called password 123, update it if I want. Either works. But now I have a legit user, two legit users actually. And now let me send the request to purchase /courses /this thing, write headers, click on send, purchase complete. Now let's see what a database looks like. The second user, purchase courses, nothing happened. So we have a bug somewhere. Most probably the syntax for this thing is incorrect and the syntax needs to change. Let me take a pause here. All right, there was a syntax error, but a good question to ask at this point is, Harkirath, how did you figure out there was a syntax error? What was my original thing? I did something like this. Purchased courses, $push, and then, course ID. This is what I was doing. And then there was an error for sure, because nothing was getting put in the database. So what did I do? I put a .catch in here. Okay, by any time there is an error, please log the error on the screen, because I know this returns a promise. This is one way of logging the error that this promise returns. The other way is convert it into an async function, do an await here, and then put this await syntax inside a try catch block. Both of them will do the same thing. And let you log the error. Okay, haan bhai, this is the error that's currently present while doing this request. There we go. This works. The other one works. Either way, I got to the log first. Okay, what is the error? If I went to Postman now, sent a request, what did it say? It said casting to object ID failed for value this. कि हाँ भाई, this I was not able to convert into an object ID. तो वहाँ से I figured out there is some syntax issue. First thing I have to do is probably convert ideally this whole thing. As you can see, what does it say? It says cannot convert this thing to an object ID, which means it expects a string here. Something I'm missing in the syntax. And that was the sort of opposite that I had to do. कि हाँ, I did not have to do this. I actually had to do push to purchased courses something, which is going to be this course ID. That was the first thing I did wrong. And how was I able to get to it? I was able to get to it by logging it a little bit of Googling also. If I run this again and go to Postman, oh, it just works. I guess this is all that I need to do. Now let's see if this actually reaches the purchases. So if I go here, you can feel free to remove the try catch if this feels, difficult or, too much of code to chew in a single point. As long as your syntax here is right and your connection to the database is right, and of course the user is sending you the right things, of course you should add some input validation here using Zod. But if everything is fine, then yeah, you can just return to the user, okay, haan bhai, purchase complete. If I now go to the database, refresh it, look at purchase courses, you will see 2 purchases for this user because I sent this request a few times. I can send it one more time and you will see 3 purchases for the user. Of course, this is for the same course, does not make any sense. Ideally, you should have different, purchase IDs here, because the same user will most probably in the real world not buy the same course twice. But you get the idea. Purchased course is being populated correctly. The only other endpoint left to implement now is how will you let the user get their purchased courses? How can they, on their Udemy dashboard, see all the courses that they have purchased currently? For that, now, where is all this data stored? Firstly, it is stored in the users table. So what do I have to do first? First, I have to get all the purchased course IDs. I can do user.find one, where the username Since the user middleware has been passed, it means I can find it here. Username. Now that I have this username, const user equal to await this thing. What can I do? User dot purchased courses is what now? Let me just log this first. Let's build this, incrementally. Rest.json message hi there. Let's log what I get when I log the user.purchased courses. Send a request to /user/purchased courses. It is a get request. Make sure you're sending the username and password in the headers. And it says message hi there. What gets logged? An array of object IDs. Beautiful. I have the array. Now I need to get all the courses for this user. How can I do that? I can do const courses equal to await course dot find, which means find all the courses where the course ID is in user.purchased courses. Now again, I might be having a syntax issue here. I might have to put in outside, unsure right now. But if this is right, then this might work. Courses. Okay, haan bhai. Find me all the courses where the course ID is in this array. So now this in is again some, one way for you to query MongoDB, and something you will learn over time. You will Google how to do a find on Mongoose where on array. As you can see, if you Google this, you reach this answer, and here it says person model.find where the favorite food of this user is in sushi or other things. Similarly, what do we have to do? We have to do in the courses table, find where the course ID is in one of the courses that this user has purchased and return that to the end user. Now, if I rerun this, go here, you will see it says empty. Interesting. I would have hoped, since this user has purchased 3 IDs or 3 courses, we see all 3 of those here. What am I missing? Where course ID in user.purchase courses, which we saw is right. Again, good debug exercise here. Hopefully a few of you can already see what the error is. But let me put a few logs now. Console.log user.purchased courses. Resend. What does it say? I see 3. Well, maybe I need to convert all of these to a string. Maybe, I don't know, s.to string. Nope, that's not it. 159. What is the course ID? Okay, let's do this. Let me replace this with this. Again, this is just to show how I debug in the real world. Still an empty array, even though I say this. Now let me do this. Where course ID? Fucking A. Hopefully you guys can see it. Like, saw this way before me. What is course ID? It is underscore ID. Where the ID is this. If I go to Postman, courses has underscore ID as this. It does not have course ID as that, right? So this is how it would work. And now, as you can see, it shows this Harkirat has bought 1 course. You might ask, Harkirat, there were 3 purchases for this user. Why don't I see the same course thrice? Because of the second MongoDB query, right? It says, give me all the courses which are present in this array. It doesn't say if there are 3 values present here, you give me the same course thrice. It says if you find a course in this whose value is present in this array, you give it to me. Even if that value is present thrice, you don't have to give me that course thrice. Just give it to me once. And that is how this user sees all their purchased courses. Let's buy another course for this user. Let's send a post request for the / course ID. So if I go to Postman, he has bought this course that ends with 159. Let's make him buy the other course which ends with 015C. Put request, post request to /user/course/course ID. Post request to /courses/course ID. That's my bad. Purchase complete. And now, if I get the purchased courses for this user, it has both the courses. They have bought the full stack course. They have bought the Web3 course. Cool. This was the assignment. I'm going to copy this over into this solutions folder. I have had a half done solution here. Let me delete it and let me copy over the solution files, specifically, the DB middleware and routes, not the node modules, just the DB middlewares and routes, and put them here in the solution. So you guys can look at my files locally as well. I'll push this onto GitHub. That is how you do the first assignment. Let me push this, and then after I'm done with this, I'm going to do the second assignment, which is actually much simpler than this one. It's not much simpler, but like most of the work is already done. So let's do that next. Feel free to take a pause. Feel free to implement this yourself. Feel free to try all the endpoints locally, the sign up endpoints, the courses endpoints, the purchased courses endpoints, and then move on to the second one, which is Mongo with JWT authentication. If you look at the README here, this one clearly says, same as the last assignment, but you need to use JWTs for authentication. We have introduced the sign-in endpoints for both users and admins. For this one, in every authenticated request, you need to get the JWT in the header. You need to send the JWT in the header. So first big difference is, okay, we need to implement one more endpoint, /admin/signin and /user/signin. And secondly, rather than sending these two things that I was sending, username and password, I need to send some token here, or like some authorization header, which, what does it look like? Bearer, the string bearer space the actual token. Good question to ask, Akirat. Why bearer? Why not send the token as such? Why do you make me write bearer space this token? When we went to ChatGPT, there also we saw any authenticated request that goes out, I send a request here. In the headers, you will see authorization header has bearer space the actual JWT. Why? It's just one, it just tells you the type of the token. There can be like various types of token. For example, it can be an API key, it can be a password, or bearer, which basically means this is the bearer, technically has a meaning, but like high level key, this is a token, or like this is the bearer type of token that you're sending to the backend. Could you work without this as well? You could, but this is standard practice to, whenever you're sending the authorization header, it has the type of the header and then the actual header, which in our case is a bearer token and then the actual token. Cool. ठीक है जी. Authorization changes, which means we don't send these two anymore. We send this, and of course the logic on the backend changes. Okay, हाँ भाई, there is a new sign-in endpoint, a sign-up endpoint, which need to return the user back a token, and the middlewares, of course, change. Okay, this middleware now needs to check and validate the headers with the token, and no longer will it get, the username and the password. It will now get the token. So this is something we need to implement now. Let's copy over some logic from our last solution. Some things we need to implement again. Specifically, at least this part we need to implement again, the middlewares. So let's maybe start with implementing the middlewares and go from there. Okay? DB remains the same, Harkirat. Literally no difference. So I can actually go to O3 Mongo DB index.js and just copy it over to O4 Mongo DB index.js. Exactly the same, literally no difference. Middlewares change a lot. Now what do you get? You get token equal to rec.headers.authorization. Harkirat, there was a capital A here. Why are you writing small a here? Because it sort of gets converted, everything gets converted to lowercase when you're accessing headers. If I, log the headers that this guy is sending, authorization will have a small a. Harkirat, how would I have figured this out if you did not tell me? You would have first done this and then figure out that there is an error. Then you would have logged rec.headers, and then you would have seen irrespective of if I send authorization or authorization, it gets converted to a small a here. So that is how I will access it here. Cool. All right, Harkirat, I understand that. Now that you have the token, what would the token look like? If the user is, sending you the right token, it will look something like this: bearer space some JWT. How do you first get the JWT from it? How do you verify that JWT? And if the verification succeeds, you need to basically let the request flow through, else you need to stop the request. This is the difficult bit now. This is where take a few breathers, go back to the JWT class from last week, make sure you understand it, and only then come here and proceed. Const token equal to this. And then first thing I have to do is get back the token from this string. One way to do that is const words equal to token dot split space, which basically means convert this into an array, the first value of which is bearer, the second value of which is the actual token, and then get the real token, or the JWT token, as words of 1, which is basically this value right here. That is how you can get this token in this variable. And now from here is where you do your JWT verifications. So first thing you have to do is cd cd o4 mongo with JWT authentication, npm install, and maybe npm install JSON web token. I'm unsure if the package.json has it. It does not. So after you do npm install, do a npm install JSON web token to actually install the JSON web token library in this o4 mongo with JWT folder. Now that you have it, import it at the top, const JWT equal to require JSON web token. Now comes the question of what we have to do here. Number one, you need to have a global secret. Whenever we've talked about JWT, we have said okay, there will be a secret that will be used to sign the token, and the same secret will be used to verify the token. We haven't yet defined that in any file. So let me go to index.js, the top level file, and at the top define const JWT underscore token equal to, secret Kirath server. You can name this whatever you want. I now need to export this. So go to the bottom of the file and write module.exports equal to JWT secret. Now this index.js is exporting this secret, which I can import here. Const secret equal to require // index. Or again, as I said, if it's index at the end, you can just remove it and it can be .. Either works. If I hover over this, you will see it makes me reach here, which means I have imported the right thing. I have imported this JWT secret here. I just need to verify it. I just need to verify this token using this secret. How do you do that? JWT.verify. The token is going to be JWT token, and the secret is going to be this secret. Const decoded value equal to this. If decoded value dot username. Now where does this username come from, Harkiyat? I will show very soon. Then call next, else call sender rest dot status 403.json message you are not authenticated. All right. What is this, Harkirath? Great question. We are yet to implement the sign-in route. How does authentication work in the real world? This is the one question we need to answer before we proceed here. Let me show you guys. The way authentication works in the real world, and you can actually go to the README and read it out. But what happens is, if this is a backend server, and this is your browser sends a sign-in request where it sends the username and password, and the server returns you back a JWT. Now, whatever authenticated request the browser needs to send, it sends the JWT along with the other body or other headers or other things that it needs to send. And this JWT it sends in the authorization header. Can it be a different header? Totally can be. But the way we are doing it right now is it sends it in the authorization header. And there also, it is basically something like authorization header, bearer space, the actual JWT. Okay, you got it back from the server. You are sending it back with every request. It's just a cleaner way to do what we were doing in the last assignment. What were we doing in the last assignment? It was कि भाई with every request send the username and password in the headers. Now it is going to be just send the JWT in the headers. This somehow just has a version of username password encoded inside. it only has the username. It does not have the password. Never put the password in your JWT, but it has a hashed version and encoded version of the username here, and that is what the middleware can use to extract your username. That is exactly what we are doing here. What am I doing? Decoded value equal to jwt.verify. Verify that this token was actually signed by me in the past whenever the user sent the sign-in request. If decoded value.username exists, which means this specific token, whenever it was created, a username was encoded inside it, send it to the next user. Tell them कि हाँ भाई, this user is good. They sent me the right token. But if there is an error, then stop the request right here. Similar to how we were in O3 assignment verifying username and password, getting username and password and verifying it from the database. Here we just encode that value in the JWT. You might ask, Sarkirat, why aren't we hitting the database? Why aren't we checking that this username and password is in the database? Great question. This is actually the reason JWT is sort of super powerful. It saves you a database call. In our username password approach, this had to hit the database, and only if it got the right thing did the request proceed. Now, in memory itself, it checks ki haan, has this JWT been signed by me? Yes, and then it proceeds. It saves you 1 DB call. This is one very big benefit of using JWTs. Ki haan bhai, you just one time sign the username somehow whenever someone is calling the sign in URL and return them a JWT. And then this JWT is enough to conjecture कि हाँ, this user is signed in. Let's go back to the newly created middleware, which is this thing right here. Let's implement the sign in endpoint, and then maybe this becomes slightly more clearer. Let's do the same thing for user.js. Notice there's literally no difference now. Ideally, when you're signing, right, you should basically, whenever you're signing the JWT, you should put the username key here and maybe the type. Okay, bhai, this is an admin or this is the user. I'm not doing that right now, but ideally, whenever you're signing the JWT in the sign in endpoint, you should have these two fields, and here you should check, okay, haan bhai, is this a username and is there type, decoded value.type equal to, whatever user in this case and admin in the other case. This is what's called authorization. Little bit, but theek hai, chodo. There's a difference between authentication and authorization. And what I was doing right now was I was showing you authorization a bit. Ki, even though the username is same, the access that they have might be different. But let's not worry about that just yet. I'm done with the user middleware. I'm done with the admin middleware. If this feels slightly difficult, it is supposed to, especially if this is the first time you're, doing JWT in production. Let's implement the sign-in endpoint and see if things get better. Let's go to admin.js. I can just copy over the sign-up endpoint from the last one. Make this async. Import admin at the top. And this is done. Sign-in endpoint. What does it need to do? Let's go back to the README. Logs in a user account. This is the input that comes in the body maybe. This is what you return to them. You return to them back a token, or specifically a JWT. So what is the input they're sending you? They'll send you a username and password in the body, similar to the sign up endpoint. What do you have to do? You have to do a JWT. First import JWT at the top. And then what do you have to do? You have to do a JWT dot sign username with this secret. And then return the user back this token. This is the bit if you understand. Of course, you should do an auth check here. Totally forgot. Const is validated equal to await user.find username password. Const user equal to this. and then only if user exists should you return them back this, else you should tell them, okay, wrong, incorrect email and password. Cool. This is interesting. I've done a few things here. Let's run this first, see if it works, and then we will come back to understanding this one more time, because this is really the gist of this assignment. Everything else is the same as the last one. The sign-in endpoint and the middlewares are the things that are different. Everything else is the same. The endpoints are just supposed to do the same thing. Only the middleware, which tells you whether or not someone is signed in, and a new endpoint that lets the user sign in and get back a token are different. So let me save this file. Let me start this specific server. Let me delete my database. So, we have a fresh slate to start with. I'm going to delete the course selling app right here. Can you delete it? Is there an easy way to delete it? There's no easy way to delete it. Never mind. I'll let it stay. I'm just going to change the name of my database to course selling app 2. 1 second, guys. Beautiful. Food has come. Food is always good. All right. I'm going to change this to course selling app 2. And now let me restart this. Yes. Let me try to hit the sign up endpoint now. Again, you might ask, Kirat, port is the same. How are you hitting the new server now? Seems like the same URL. Yes, but I'm now starting it in O4 Mongo with JWT auth. I'm not starting it in O3. This one, which is why I'm now starting the new project. I can totally just delete this old one, the O3 Mongo, because I'm not starting it is why this works. Now the problem is, okay, my database has suddenly stopped responding. Let's see why that is. Let me go to MongoDB Compass. Let me restart it. Try to connect it here. I suddenly not responding. Most probably MongoDB has blocked me, stopped me. My credentials were leaked. I don't know. Let's see. Let's go back to project overview. Let's refresh. Free shared view deployment. Seems to be working as expected. Nothing too wrong in here. Let me figure this out. All right. I did nothing and it started to work. My database was having a day. Most probably when you're using, a free instance of MongoDB, it can go down from time to time, which is probably what happened. Now if I restart the process, or even if I go to MongoDB Compass, you can see I'm able to connect to my database. I've changed the database to be course selling app 2. And if you remember, we had already created 2 endpoints, the sign up endpoint for an admin and the sign in endpoint for an admin. And this one does return back the user a token. Let's see if it works as expected in Postman. So /admin/signup. Let's send somebody username and password. And when I do, it needs to be a post request. And when I do, it says admin created successfully. And if I go back to MongoDB Compass and I refresh, I see course selling app 2, which has an admin table, which has the first user or first admin right here. Now comes the most important bit, the sign in endpoint. If I click on the send a request to /signin, my server dies, which basically means we have had some issue. Secret or JWT secret is either not being exported. It is being exported. It says secret or private key is not valid key material. Interesting. Let's log JWT secret and make sure it actually is the string we're expecting it to be. Maybe let's log it in the /signin endpoint. Let's restart and hit the request. And interestingly, JWT secret is an empty object and not a string. Let's try to export it like this. Module.exports equal to JWT secret, an object where this is the key. And when we're importing it, let's import it like this. Now let's see if it works. Oh, circular dependency. Yeah, that isn't great. Okay. Yeah. So this is doing is creating a circular dependency where index.js imports admin routes and admin routes imports index.js. So this is what is, they'll just basically keep, re-importing each other. You can actually get around this, but the cleanest way to do this is either create a new file here, call it, whatever, jwt.ts, or usually you call some, in the real world, you create a config.ts file or whatever, JS file, because we're not yet in the TypeScript realm. And here you can do module.export equal to JWT secret, which is your JWT secret. Let's remove it from here. Let's make index.js not return anything. And let's go back to config.js. And here I'm going to export this. Now I need to import this in everywhere. So if I go to middleware/admin.js, secret ki jagah, it will be JWT secret from /config. And rather than using secret here, I'll use JWT secret, and same for the other file. And lastly, in our admin route, I need to import it again from /config. Now if I restart this, also have to use it the right place. Oh, we are already. So if I restart this, and now if I hit the sign in endpoint, does it work? It does indeed. We get back a JWT token from the backend anytime I try to sign in. This is nirvana. This is the biggest sort of thing you need to understand in authentication. Okay, whenever you are on a page that looks something like this, like a sign up page or a sign in page, and you do a whatever email password sign in, the request that goes out gives you back a token. And now in any future request that you want to send, be it a request to, sign up, create a course, get all the courses, you can just send this token over in your authorization header. Bearer space this. The only difficult thing here might still be like, why this, Harkirat? Why can't I simply send the token as such? Why bearer? Just standard, just practice, just convention to define your authorization header. You can totally, not do this. You can totally just send the token as such. And in your middleware handlers, you can simply not do any of this logic and simply get back, JWT token here. Don't have to do any of this. Depends on how you want to structure your app. In our case, the requirement was you have to send something like this, bearer space the token, which is why that's how we are decoding it here as well. Cool. Let's implement one endpoint that lets you maybe create a course. Again, I can just copy this over. Literally nothing has changed from the last assignment. The only thing that has changed is the authentication logic. The logic here is pretty much the same. So if I go to Mongo routes admin.js here, I can literally copy over the /courses endpoint, paste it here, and let's see if it works as expected. Is it able to create a course or not? I can actually go back to my history here and find one of the endpoints that I might have used to send a request to create a course. Never mind, let's just create a new one. Write authorization header, and in the body title, let's call it full stack course. Description, full stack course by Harkirat, and then price $5,999, and what was the fourth thing? Image link, which is whatever a.png. All right, let's try to send a request to /admin/courses or course. What is it? It is /admin/courses. Sorry, the post request is, courses. Post request looks fine. Send the request. It says JWT must be provided. Headers has the right thing. Great, we found a bug in our admin middleware somewhere. Oh, did I forget to implement? Oh, we're in the wrong assignment completely. Let's go to o4/admin middleware. There is an error that comes here. You can see JWT must be provided. Let's see what JWT token gets logged as. Not index.js. Admin middleware. Is the control even reaching here? I don't think it is. It is. And what is token getting logged as, or this thing that is getting logged as? Nothing, which means most probably this token as well is not reaching the backend. Let's log the headers. What all headers do I see? I see a bunch of them. Do I see authorization? I do see an authorization header. Is my spelling incorrect? No, that looks right as well. Is token.split space. Oh, there are two spaces here. I'm sending the wrong input. I'm sending two spaces here. Need to send only one space. Now let's try it. All right. What I was doing wrong was I was not sending the right input here. There were two spaces here. Now I've made it a single space. And now if I go back to admin.js middleware, let me remove all the logs. Restart the app. Send. Course created successfully. Got back a course ID. If I go to MongoDB Compass now and go to courses, you will see a course has been added here. But in headers, what am I sending? Am I sending username and password now? No. I'm sending bearer space the token. This token gets extracted in this admin middleware. I get the token, which is the whole string, basically bearer space the actual token. Here I split it and create an array. Bearer space the actual token. Then here I get in this JWT token the actual token. And then I verify the token using this secret with which we originally signed it. And if I get back a username here, it means ki bhaiya, let this proceed. This was probably signed by me only in one of these sign in endpoints. So that is, one way, probably the right way to do authentication until we reach cookies. What have I done? Let's look at it one more time. I have a sign up endpoint, which lets the user sign up. I have a sign in endpoint, which lets the user sign in. I have a courses endpoint, jahan pe the admin middleware first needs to approve the request. And what does this guy do? This guy checks the header for the authorization header, gets the actual token and does a jwt.verify. Verifies that this token was actually signed by the secret that only the server knows. And if that is true, if decoded value.username exists, it means that you're good to go. The courses endpoint can actually create a new course. Now there is the fourth endpoint to get back a course, which I'm hoping is straightforward. I can actually just copy paste over the solution from the last assignment because the get request will be exactly the same. We're almost done here. There's just one nuance that one more thing we need to figure out. Let me go back here. Let me implement the get endpoint as well. Again, admin middleware is still being called, but this is a new middleware now. This is not the old middleware from the last assignment. Let me restart. Let me do a get with the right JWT here. And I get back the current set of courses. If I send the wrong JWT, I get back an error. Ideally, we should handle this error slightly better on the server, which we can if you want. Go to middleware/admin.js from the fourth assignment. And then, put this inside a try catch block. And if there is ever an error, you can return back, incorrect inputs or whatever you want. Now, if I send the same request with, the wrong inputs, it says incorrect inputs, which is a slightly better thing to show than showing, that whole exception. Great, Harkirat. This works. One thing that is left. You have implemented the same thing for the user. If you go to user, sign up endpoint should be straightforward. Sign in endpoint should be straightforward. Courses endpoint should also be straightforward. This endpoint will be slightly tricky. I'll tell you why. in this endpoint in the last assignment, what did we do? We said, okay, bhaiya, if someone wants to buy a certain course, I need their username. And this username was part of the headers. The user was sending us their username. So we knew, this is the user, this is their username. We did a user.update one, pushed this course to their purchased courses. But now we don't have a rec, const username is not rec dot headers dot username. The user is not sending us this. So we can't purchase them because we don't know who the user is. You might say, Harkirat, let's just ask the user to send a username along. Well, you could do that, but then there is one big security vulnerability here. Okay, he might send the token of one user, but username of another user. And you will, for user Harkirat, even though the cookies were for user Harkirat or the token was for user Harkirat, you gave access to user 2 or user Raman, which is not great. So this definitely is the wrong approach. The better approach is, okay, in this user.js, you were able to find the username, right? Put that username in the request object. Request.username equal to decoded volume.username. Value.username. Why? Because whenever you're using middlewares, whenever you're propagating from one middleware to another, if you remember from a few slides ago when we understood middlewares, I told you, okay, bhai, these middlewares are actually supposed to do a few things. What were the few things that middlewares do when a request comes? Either end the request or forward the request, or one of them was pass data along to the next middleware. That is exactly what we want to do. This guy is decoding the username. It needs to pass the username to the next guy. This guy's job is to take the GWT, get back the username, and put it in. One way for it to pass it to the next guy is put it in the request object, so that when this guy accesses rec.username, it is able to get back the specific username for this user, whoever is sending the request. So what did I do? Number one, here I did a rec.username equal to decoded value.username in user.js ka middleware. And in the routes, I said, ke bhaiya, anytime a request is coming to /courses/course ID, I'm going to do whatever logic I had here, I will do. But am I getting back the username for this user? That is the interesting thing. If I'm getting back the username for this user, I can write the rest of the logic to, put something in their purchases. If I refresh, if I go to Postman and now send a request to /user/courses/ some random ID, which is a post request. JWT is not defined, so I probably need to import JWT here. Web tokens, all of this will be much better once we reach the TypeScript bits. Now this request is hung and undefined got logged, which means rec.username actually did not propagate logging rec.headers.username. Now try it one more time.